Okay, good morning, class. So at this point, we're looking at probability. In our previous lesson, we marked part or most of exercise 1. And then we went some of exercise 1. Then you guys made a noise, so you couldn't get through that. Then we did exercise 2, but which we haven't completed. Is that correct? In exercise 2, we got up until H. Exercise 2 on page 315H. Okay, so here we are told that the number of pens in 10 containers are as follows. You got 37, 35, 34, 38, 33, 35, 36, 37, 34 and 35. One container is selected at random. Okay? Determine the probability of choosing a box container. So if you look here, we got 38 pens. How many containers has 38 pens? 1. So one container, the probability of a container containing 38 pens, morning, is going to be 1 out of. Can you see that? The container containing 35 pins. How many 35s are there? 1, 2, 3. 3 out of 10. The container that contains more than 36 pins. So the container that contains more than 36 is going to be 37, 38, 30. Can I consider 36? No. Why? It says more than. Then 37. That's it. It's 3 out of 10. You guys understand? Any confusion there? The next question, we are told that a letter is chosen at random from the word probability. A letter is chosen at random from the word probability. So how many letters are there in the word probability? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How you get 12? Did you do your homework? Not this question. Okay. So the question says, determine the probability of choosing. Number 1, the letter A. So how many A's are there? 1. So the probability of choosing a letter A is 1 out of 11. Number 2. The letter P. How many P's are there? 1. It says 1 out of 11. Number 3. The letter B is 2 B's, which is 2 out of 11. Number 4. The letter I. 2. So it's going to be 2 out of 11. Number 5. A vowel. How many vowels? What are vowels? A, E, I, O, U. So it's going to be A, E, I, O, U. Any of these letters. How many A's are there? 1. So it's O. 1, 2, 3, 4. There's 4 vowels there. Is that correct? So it's 4 out of 11. Number 6. The letter C. How many C's are there? 0. So 0 out of 11, which is 0. Number 7. Number 8. 7. The letter A or I. How many A or I's are there? There's 2 I's and 1 O. So it's going to be 3 out of. So it's going to be A, O, or I. What do we also call that? Or, yes. Another way? So the U. Union. Okay. There's 3 out of. Now, do you guys understand? Then the last one, J. At an event promoting frozen yogurt, the organizers put out a whole lot of cups containing different flavors of yogurt. People could pick any flavor cup to taste the yogurt. The histogram shows. This is actually not a histogram. What type of graph is it's actually a bar graph. Okay, because what would have made this a histogram? Yes. Touching each other, yes. And this is an example of discrete or continuous data. Discrete. So if we consider, it can actually be counted, the number of people who took this particular flavor. Can you see that? Whereas continuous data is when we're talking about heights or weight of people. You understand? So it's not everybody that is 1 meter tall or 2 meters tall. We have people that is in between. So that is continuous data. In continuous data we draw histograms. Okay, so this, for this data set, even it is a bar graph, because that's discrete data, can be counted. Okay. So, hello? Okay. So it's supposed to have been a bar graph below shows the number of units per flavor, determine the probability that the person will pick. So if you look here, what is this? Bubble gum, no? And this? Candy. This one here? Chocolate?
Cheesecake.
This cheese. Okay, I can't see so little. The first one is cheesecake, no? Chocolate. I'll make it a bit bigger. That's my favorite. What's your favorite?
Bubble gum.
Bubble gum. English stuff is fairly good. Yes. Then? What's this? Lemon. Yes. This? Mango. Mixed berry. Banana. Watermelon. I never tasted that one. Sounds good. Right, so let's look at number 1. So, what we need to note here is that in the first category, there's 35, not so. Then the next one is 15. The next one is 15. The next one is 20. This one here, 45. The next one is 40. The next one, 50. The next one, 30. Next, 5. And the next, what is that? 30. So if I add all of this up, what do I get? Sorry? 285. So that is the number of possible outcomes, the number of possible people. Not so. So the first one is determine the probability that the person will pick. The first person picking chocolate. Chocolate comes in at, this one, it's 20 out of 285. So let me just align this board. I'm not playing games with myself. Right, so we're going to just so chocolate's going to be 20 out of 285. That simplifies into 5 goes into 24 times, 5 goes into 285. 5 carry 3, so 57. Is that correct? Right. Number 2. A mixed berry. The probability of mixed berry. So how many mixed berries are there? Sorry? 30. 30 out of 285. Which gives you an answer? Assalamu alaikum. Sorry? 6 out of 57. Number 3, English toffee. English toffee. 45 out of English toffee. 75. It's 45. Is right. 45 out of 285. Gives you an answer of 9 over 57. Remember, we always simplify. Eh? Probability of watermelon is 30 out of 285. Simplify that. Vanilla or cheesecake? Vanilla, which is 5, or cheesecake? Cheesecake is this one, 15. So it's 280 out of 285. You simplify that. Okay? Any confusion? No? Now we're looking at using probability to make predictions. This is example 4, and it's on page. Example 4 is on page what? 317. Example 4 on page 317. So now we're looking at a dice rolled 300 times. Predict how many times you will expect to roll a number greater than 4. Alright, so if you're looking at the die, how many outcomes are there? 6. What are my outcomes? 1, 2, 3, 4, 5, and 6. So a number greater than 4, it can be 5 or 6. Not so. So how many outcomes are there? 2. So it's 2 out of 6 chance that it will be a number greater than 4. But here they want to know if it's rolled 300 times. So what we do is, we take this probability and we multiply it by 300 over 1. So 2 going to 2 once, 2 going to 6 3 times. 3 going to 3 once, 3 going to 300, 100 times. So therefore, approximately 100 times it will land on a number greater than 4. You guys understand? Will it land exactly 100 times if I flip a 3, if I toss a coin 3, the die 300 times? No, it's just approximation, okay? Any confusion here? No? So here's exercise 3 now, okay? So what I'm going to do is I'm going to give you a chance to answer the first 2 questions, then I will do it on the board, okay? This is exercise 3 on page. This is on the same page. Sorry? Page 317. I'm going to pause the video at this point. Okay, so at this point you should be done. We are told in exercise 3, a die is rolled 600 times. predict how many times you will expect to roll the die, roll the number 5. So how many 5s are there? Probability of you hitting a 5 is 1 out of 6 chance. Not so. So the number of times will be 1 out of 6 multiplied by 600, which will give me 100 times. Approximately 100 times. Okay, you all agree with that? Let's look at B. A die is rolled 3,500 times. Predict how many times you will expect to roll an odd number. If you're looking at the odd numbers on the die is 1, 3, 5. So what's the probability there? 3 out of 6. So therefore, it is 3 out of 6 multiplied by 3,500. So what we do from here is we simplify. Okay. So 3 going to 3 once, 3 going to 6 twice. 2 going to 2 once, 2 going to 3,500. 1,750 times. Not so? So that would simply be 1,750 times. Okay, any confusion there? No? I'll give you a chance to do number C and D quickly. For homework, I would like you guys to do the revision exercise. Okay? And that is going to be our last lesson on syllabus coverage, and then we're going to past papers. Did I give you last year's paper already?
Yes.
When we started working on that, no? So hopefully Monday we will have a look at that. Okay? As well. I gave you a few questions to do already, no? 1, 2, and 3. So just hang on to that before you carry on. For those of you who have nothing to do after the revision exercise, you can carry on if you like, okay? There's a lot of papers. We got about 2 weeks in which we're just going to do past papers. Okay? To ensure that you guys do well in your final exam. Okay, so I'll pause the video again. Right, so we are told in number C, or in C, a spinner has equal number segments. So how many segments are here? 6. Number 1 says, what's the probability of obtaining the number 4 on the first spin? So how many 4s are there? 1. So probability of you landing a 4 is 1 out of number 2. What's the probability of obtaining a factor of 4? So what are the factors of 4? Factors, the probability for the factors of 4. There's going to be 1, 2 and 4. So it's going to be 3 out of 6, which is number 3. How many 3s would you expect in 1,000 spins? So firstly, the probability of 3 is 1 out of 6. So therefore, 1 out of 6 must be multiplied by 1,800. Not 18,000. So 6 going to 6 once, 6 going to 1,800, 600 times. 300 times. Answer is number 4. Okay? What's the probability of obtaining the number 3 in 600 spins? How many 3s would you expect in? Sorry, ma'am, is this nonsense? Hello? Give this up. Listen, I'm just going to close me at the moment, so anyway. I'll call me after 3. Yes. Okay, so what's the probability of obtaining the number 3 in 600 spins? So it's going to be, the probability of 3 is still 1 out of 6, not so. So it's 1 out of 6 times 600, which is 100. You would agree with that? So what's the difference between the two? It's only the number of spins by the looks of it, no? Right, let's look at the next one. About 1 in 5 people in a company gets really sick every month. Okay? How many sick people would you expect to find in a company employing 100 people? So again, 1 out of 5, the probability is going to be, for the probability of people to get really sick, is 1 out of 5, as you can see there. Okay? Why am I writing 6? Maybe I'm also sick, no? In the head. So 1 out of 5. 100 people, so it's going to be 1 out of 5 multiplied by 100 over 1. 5 going to 5 once, 5 going to 100, 20 times. So the answer is approximately 20 employees get really sick every month. Okay. This is the last one in this exercise quickly for the bell rings. Again, I'm going to pause the video. Right, so here we're told in a pack of 52 cards, all the aces, jacks, kings and queens are taken out, as well as all the number 6 cards. So what do we have? We got jack, queen, king, ace, and 6. So 4 of each, all the suits. There's 1, 2, 3, 4, 5. So it's 5 by 4, which is 20 cards in total. Okay. The cards are placed on the table. So you've got 20 cards on the table. Number 1. How many cards are in the table? 20. So there we go. Okay, you all agree with that? Let's look at number 2. Number 2 says, suppose that the card is selected from the table and then replaced. So they take one of the cards and they put it back on the table. Okay. This is done 500 times. How many times would you expect to select an ace from the table? What is the probability in this situation? So what is the probability of you selecting an ace? The probability of an ace is 4 out of 20, which is 1 out of 5. Not so. 4 out of 20 is 1 out of 5. But when that card is replaced back on the table, the probability again remains the status quo, as it is. Not so. 1 out of 5. It is when that card is not being replaced, then the probability changes. You guys understand? So that probability is going to remain the probability for 500 times. Okay? So the question is, what's the probability in the situation? The probability is 1 out of 5. The question where it says this is done 500 times, how many times would you expect to select an ace? So that's going to be 1 out of 5 multiplied by 500, which is approximately 100 times. Who got that right? Nice. Good. Right, you guys understand? Okay. So that now brings us to the revision exercise. You guys can start with the revision exercise now. Again, I'll call you row by row to ensure that you guys know what you're doing. Okay, I'll stop the video at this point.